Solving CTF is one of the best way to level up computer security skills. Because CTFs are intended mostly for beginners, so for the student like us, it is the best place to practice and refresh our basic concepts. Today we will be solving 12 CTF challenges from the general skills category in picoGym practice challenge. And we will learn some really good and basic stuff that we must know about. These 12 CTFs are divided into four groups. The first three are warm up, which require us to have the knowledge of different number systems like base 10, base 2, etc., and conversion from one base to another. After that, next five challenges are all about different Linux tools which can be very useful when it comes to extracting information from a large file or making connection to other host machine. Then we will practice some Python and C stuff, and finally we will explore some Rockstar programming concepts. So let's do it. The first one says that can you convert the number 42 of base 10 in binary of base 2? The number nearest to 42 which can be represented in power of 2 is 32, which is 2 to the power 5. After subtracting it from 42, we have 10, and the number nearest to 10 in power of 2 is 8, that is 2 to the power 3. It leaves us with 2, which is 2 to the power 1. So the 42 in base 10 can be written using 2 to the power 1, 3, and 5. Therefore, 42 in binary is written as 101010. The next one says that what is the decimal value of hex value 3D? To convert a hex value in decimal, we will first convert it into binary and then we convert it from binary to decimal. One hex value can be represented in 4-bit binary. So 3D in binary is written as 00111101. Now the places where 1 is present are 0, 2, 3, 4, and 5. So the decimal value of it is the sum of all the 2 to the power places where 1 is present. Therefore, the 3D in decimal is 61. The next challenge description says that if I told you a word started with 70 in hexadecimal, what would it start with in ASCII? To find out the ASCII character from hex value, we have to use the ASCII table. So open the manual page of ASCII by typing man ASCII in the terminal. So the ASCII character for 70 in hex is P. The next challenge is strings it. It gives you a file containing the flag and we have to find the flag without running this executable file. The hint is strings. Strings is a command line utility in Linux. It prints the sequence of printable characters in files. So as we have an executable file and an executable file can have many sections like elf header, program header table, code and data section and section header table, we will use option A in string command to scan all the sections of the file. Let's run the command. As it said, it printed all the printable characters of the file. Now finding our flag in this whole list is quite difficult. But there is one tool in Linux called grep that can help us. Grep stands for Global Regular Expression Print. Let's see the manual of grep. It says that grep prints each line that matches the pattern. Let's say we have a text file full of random string, then we can find the line where our pattern matches. Now to find the flag in output of string command, we have to pass it on to grep. To do this, we can use piping. Piping redirects the standard output to some other command. Let's run this string command again and pass the output to grep through piping to find the text picoctf, and it returns the line containing our flag. Next challenge description says that what does this string mean? I think it has something to do with bases. As we have seen that the base 16 uses digits 0 to 9 and alphabets A to F, while base 32 uses all the uppercase alphabets digit 2 to 7 and equal to for padding. but the given string contains digits and all the upper and lowercase alphabets. So probably it is base 64 encoded. To decode this, we can use command line utility base 64. It encodes and decodes the data of a file and prints to the standard output. So let's put the given string in a file and decode it with base 64. It decoded it and printed out our flag. The next challenge is first grep. It gives you a file with lots of string and wants you to find out the flag from it. As we have seen earlier, we can use grep utility to do this tedious job and find out the line containing picoCtf. And here is our flag. The next challenge is to get the flag by connecting to the given server at given port using Netcat, which is also very famous as Swiss Army knife. The Netcat is a simple Unix utility which reads and writes data across network connections using TCP or UDP protocol. So to connect to the given host, type nc hostname and the port number. For an inbound connection, we can also specify the L option. As soon as we get connected to the host machine sends us our flag. The next challenge is plumbing. It says that sometimes you need to handle process of data outside of a file. Can you find a way to keep the output from this program and search for the flag? Connect to the given host at given port. Remember, when we were solving the string set challenge, we have used piping to redirect the output to grep command. Here also we will do the same thing. Connect to the host and redirect the output to grep to find the flag. And here is the flag. The next challenge says that to get truly lit, you must understand different data encoding such as hexadecimal or binary. Can you get the flag from this program to prove you are on the way to become lit? And then it gives us a host and port to connect with. So here we will deal with different data encoding scheme. Let's first connect to the host using Netcat. The host machine gives us a word encoded in binary and we have only 45 seconds to decode it. If we see the hint, it says that I hear Python can convert things. So we can write a Python program to decode the number strings encoded in different bases. First we will take the type of base encoding and the number string as input. Then we have to split the number strings by spaces and put it in a list cipher. Now we have to loop through the list and convert each number string from other bases to base 10 and then into ASCII character. Let's connect to the host and also run our base decoder in another window. Now decode this binary string and input the decoded word. The host machine accepts the input and gives us another string of number, but this time it is encoded in octal as the value are greater than 127 and there are only 128 ASCII characters. So this time enter the encoding scheme as 8 and decode the given string. The machine accepts the decoded word and sends us another string encoded in base 16. As one ASCII character can be represented by two hex value, we will put a space after each pair of hex value to decode it. And by submitting the decoded word, we captured the flag. The next challenge, Flagshop, is quite interesting. It gives us a source code file written in C language and says that there is a flag shop selling stuff. Can you buy a flag? Let's first compile the source code and execute it. It gives us a selection menu to perform some actions. First is to check account balance, second is to buy a flag, and third one is to exit the program. Let's first see our account balance. So we have a total of 1100 in our account. Now let's try the second option. It shows us two flags. Let's buy the first one. It says this flag will cost you 900 for each and ask us to enter the desired quantity. We will put 1 here for now. After that it gives us information about the remaining balance in the account. Now let's try to buy the second flag. Its cost is $100,000. When we enter 1 to buy this flag, it says you don't have enough funds for a transaction as we have only 200 left in our account. Even before buying any flag, we had only $1,100, which is much lower than the price of the second flag. Let's see the source code now. Here is our account balance 1100. And this if block code is to buy the first flag, while this else block is to buy the second flag. And before any transaction, it calculates the cost and compares it with the available account balance. Now, to buy the second flag, we must have the balance more than $100,000. And in this source code, this is the only place where account balance is getting altered. Here we are subtracting the total cost from account balance. But if we can somehow manage to make the total cost negative, we can turn this subtraction into addition, which can increase the account balance. And note that you cannot have the quantity of the flag in negative value. It seems that there is no way to make the total cost negative and increase the account balance. Let's see the hint. It says that 2's complement can do some weird things when numbers get really big. Hmm. Did you get anything? In C language, the size of the int variable is 2 or 4 byte depending upon the architecture of the system and compiler. Here in our case, the variable total cost is a 4 byte signed integer. That means it can be used to represent the value within this range with the most significant bit as a signed bit. So to increase the account balance such that we can buy the second flag, we will try to make this total cost around negative 100,000. To do this, we have to find a large positive number such that it is equal to the number negative 100,000 in 4 byte signed integer. This is the binary representation of negative 100,000 in 4 byte signed integer. By converting this binary string into decimal, we got this number. So now we know that to make the total cost negative 100,000, we have to actually make it 2,147,583,648. So the number of first flag that we should enter to make the total cost negative 100,000 is around 2,386,204. Let's run the executable file and enter this number of flag. As you can see that it has increased the account balance. Now we can buy the second flag. It is telling us to run this on the server. So let's connect to the server and do the same thing. First buy the first flag in large quantity to increase the account balance, and then buy the second flag. And here is our flag. The last two challenges are about the Rockstar programming language. Rockstar is a dynamically typed Turing complete programming language designed for creating computer programs that are also song lyrics. Here the word Turing complete refers to the capability of programming language to compute everything what a Turing machine can do. And this is how we write the program in Rockstar. This language is a type of esoteric programming language, sometimes also called as isolang. Esoteric language or isolang is a computer programming language designed to experiment with weird ideas, to be hard to program in or as a joke rather than for practical use. To know more about this Rockstar language, you can watch this talk given by the creator of Rockstar, Dylan Beatty, at .next conference. After exploring this language a little bit, you will be able to solve these two challenges easily. So that's it for now. I hope you enjoyed every bit and thanks for watching. See you.